Hello everyone, today we are going to do a video a little bit unusual for me, given what I'm mostly publishing. It's going to be a talk, a discussion video, what other tech tubers do a lot. Well, I thought I'm going to give it a try because there is this important thing I need to talk about with you. We are going to discuss fans, and specifically how fan manufacturers, with their product pages and what they publish as tech specs, are lying to us and give us useless information, completely useless information. But before we go to that, let's start from the beginning. Recently, I took a task of replacing my stock case IO fans for something better and more quiet with higher performance. As probably great majority of people, I started browsing websites and sort fans by static pressure, airflow, and so on, because the higher the number, the better the fan is, right? Well, you couldn't be more wrong. Thanks to some smart people over at Overclock.net, I realized how big and massive mistake it is to even look at the CFM and MMH2O parameters posted by fan manufacturers. And to spread this awareness, I made this video. Hopefully some people who watch it will never make the mistake I do. Okay, to start off, first of all, the airflow and static pressure specs listed at fan sheds, over at shops selling fans, and even at manufacturers' websites who publish product pages. The air pressure, the fan airflow, are actually called maximum static pressure and maximum airflow. Some fan manufacturers even omit the maximum word and lists them just as airflow, CFM or cubic meter per hours, or static pressure millimeters H2O. And what is wrong with that? The thing is, maximum airflow is measured when there is zero resistance. Basically, fan does not need to generate pressure to move the air, meaning this is a situation when you put a fan vertically on top of your desk and let it blow forward. Nothing in the way of air, it can just blow all the way it wants. Situation like that is completely unrealistic and is never happening in real life use of PC fan. Even a simple case grill, a filter will create resistance on the path of air, and then maximum airflow that is listed on every manufacturer website has no use. It's completely useless. The maximum static pressure, or just static pressure, that manufacturers list is measured when there is zero airflow. That's right, zero airflow, meaning it's a situation when you put a fan flat on the table and force it to spin and blow air toward the table, practically blocking all the air going out. And again, this situation is absolutely unrealistic and has no real world use. This parameter is useless again. So, fan manufacturers are trying to lure you into buy the products, giving you useless information that has no real life use. What to look then for? What do we do now? The answer is PQ curve. A PQ curve is relationship between static pressure generated by fan and the flow rate. This website here, RxGroup, describes this curve, this characteristic very well. It's very helpful if you want to understand it thoroughly, but in a big shortcut, a summary of PQ curve. The PQ curve is measured by locking fan in a box. There is a fan, the box, outside the box, we measure the airflow that comes out of the box. The first situation is this one. There is a fan, the airflow is completely blocked. There is zero airflow, so fan produces maximum pressure, static pressure, and this is what the case manufacturers, fan manufacturers are listing on their pages, the maximum static pressure. Absolutely useless situation. You can see it now even from the picture. Now, the PQ curve is produced by slightly opening the box and letting out more and more air. Once the box is open, the airflow increases, just like you can see here, and because the air has a clear way out, the static pressure generated by fan is dropping, just as you can see here. And the box is opened, and finally it's open wide. The air can freely get out of the box, so the airflow is maximal, while the static pressure is zero. Again, this is what fan manufacturers list on their product pages. Maximum static pressure, maximum airflow, both useless. But why they are useless? What's the point in here? Let me show you an example PQ curve of two fans, Gentle Typhoon AP and Kogura Vortex PWM. Let's look at the left side. We have the static pressure posted on the websites of fan manufacturers. On the first look, you would think that Kogura is better fan than Gentle Typhoon because it has higher number. But we are wrong. Once we follow the PQ curve of the fan, we are reaching this section, the middle of the curve. This is a situation when the test was performed and the box was half open, half closed. Practically, it can be described as a situation where we have fan mounted on the radiator, and the radiator is so dense that it's blocking physically half of the air that comes out of the fan and letting through the other half through. So in this situation, a real-world situation, we can see that the curve is shaped differently. We can see that the weaker fan actually has higher static pressure in this situation and higher airflow than the Kogura Vortex in here and here, meaning that in real life scenario, a fan with lower max airflow, lower airflow that was listed by manufacturer, and lower static pressure that was listed by manufacturer is actually better than the fan that had higher numbers. This is the point of everything. This is the exact reason why you should never trust the max airflow, max static pressure numbers posted by fan manufacturers, and you should look for PQ curves or real life tests. Okay then, so your world is shaken, your whole life was a lie. What to do now? Where to look for these PQ curves and real life fan performance? Well, there are few ways. First way is look for reliable people who benchmark fans and describe their benchmarking methods properly, so you know what you are exactly looking at. One website I found in my adventure to find my new case fans is Thermal Bench. The guy is professionally benchmarking fans and has his own method of measuring the parameters. It is not a real PQ curve fan curve, but he does provide some good information. Let me get to it. Yes, he has his own testing methodology with some measurement equipment, and he can produce quite nice results from measuring airflow at different fan RPMs. Unfortunately, this guy can't measure the static pressure because it requires some more equipment, but this is a great source of information. The second thing is this site, coolingtechnique. This is absolute holy grail of your insight into real life performance. These guys over here have fully professional studio for measuring not only the noise generated by fan, but also all the parameters of airflow, of the static pressure, according to the industrial standards. This website is half Italian, half English, and few other languages, but all of the fan reviews are in several languages, so it's good. And as you can see, through their tests, they are able to measure the real life performance, PQ curves, the static pressure values, CFM of different fan, and they did a lot of it. So this is your to-go source of information. But beside these testers, the thing we all should do is ask manufacturers directly to publish their fan PQ curves. The manufacturers right now are good with giving us useless information, but if we all start acting, it might change. For the purpose of my quest to replace fans in my case, I started sending out mails to several fan manufacturers, popular ones and less popular, asking them for PQ curve. The answer I got were very interesting, how differently each of manufacturers reacted to my questions. Now I'm going to show you the results of my little survey. First of all, we have Corsair. I asked them about their ML fans, the ML140 and HD RGB fans. The answer was hilarious. Corsair even didn't know what a PQ curve is. They told me it's available in their software, and when they see the curve word, they actually automatically assume I'm talking about the RPM curve where you set fan speed. This was the absolutely hilarious answer. I tried to escalate it to some kind of product manager, and I'm still waiting for response. So yeah, this is that one. Next one, we have Fractal Design. I asked Fractal Design for the Venturi HP fan, and to much surprise, they answered right away. The answer was very fast, and they gave me exactly what I asked for, the PQ curve of their fans. Interesting thing to note is that PQ curve has to be measured it has to be measured at constant RPM. So to fully see the fan performance, we have to measure, for example, multiple PQ curves for multiple RPMs. And I got from them a 400 MPM PQ curve. Very nice of Fractal Design. I will certainly look for them in future for helping their customers. Next one is Noctua. Noctua is seen by communities as the way to go for fans, the professional company, and my expectations were met here. On the very first reply from their customer support, I received a full booklet of static pressure curves, the PQ curves. It's very detailed. We have PQ curves at different RPMs, and this one is for NFA 14 fans. It's related both to the standard NFA 14 fans and the industrial versions. Very nice data, very prompt response. Props to Noctua. Next one is BeQuiet. The response from BeQuiet was absolutely outrageous and infuriating. BeQuiet at first replied to me in kind of broken English that we don't have the curve to communicate outside of the company. And when I tried to escalate it to some kind of technical manager, etc., I got a straight answer. The manager of BeQuiet customer service told them they are not allowed to share PQ curve information to customer, to the externals. This means they are allowed to only give customers useless information and not what actually tells us truth about fan performance. I will never buy any product from BeQuiet, not after this. This is the worst kind of customer support when they admit that they are not allowed to publish unessential information. Next is EVGA. EVGA was one of my biggest disappointments. A company that is advertised as for extreme enthusiasts, etc., doing high quality products. They replied to me that PQ curve is not available at all. After that answer, I of course tried to escalate the issue, but my mails were ignored. So later I had to escalate it manually to the director of technical marketing, and I'm still awaiting response. I will make a follow-up if I receive anything. Next is NZXT. NZXT was biggest surprise. NZXT is seen by many people like a company that does pretty stuff, but not really useful, not very technical, professional. At first, the CS rep from NZXT told me they don't have a PQ curve of the fan, but they gave me a contact info to the product manager, and they were able to got me the PQ curve of the NZXT IRP, RGB or not fan, the flagship fan. So this is a big positive surprise on the NZXT side. They grow in my eyes a lot. So that's it. EKWB, the custom lab company. They have their own branded fans, and given they are selling products for high-end PC users and enthusiasts, as expected, they provided the PQ curves of their fans on the first request without any issues. Great response. Hopefully more companies will be like this. We are going to the end. BitFenix, a smaller company, not that well known, but to my surprise, they got me a PQ curve really nicely. I had to remind them about it because it took a little bit long to answer my email, but in the end, they sent me a nice spreadsheet with all the information I needed. So props to BitFenix for nice response. They were much better than EVGA and BeQuiet. So this is nice. There are still companies like this. Okay, so that was a lot of information. Think through. Have all these curves, all this data. It would be nice to have one place to compare everything. So, beside these websites, where coolingtechnique puts combined graphs for different fans going at different RPMs, etc. From here you can start reading which fan is better than other. This is the situation I'm talking about. For example, Corsair Aero Series is P120. would be seen as much better than this kite glide stream because it has higher numbers, but in the middle of curve it goes down like this. The perfect PQ curve of a fan would be the one that goes flat like this and only drops somewhere here at the maximum CFM. It maintains a high static pressure through variety of the airflow, and that would be our perfect curve. So I was talking about somewhere to compare the fans. Well, all the sources you've seen from me, the information I got from mails from different companies, I created this Google spreadsheet in here where you can see them on a large graph, and I already placed 20 fans from the information I got from different manufacturers. Also, I put in here information from this website, coolingtechnique. I'm actually stating in here, if a fan has node that is official, it means the PQ curve comes directly from the manufacturer, and if the fan has no official word in it, it means it was tested by the coolingtechnique. And this is kind of my contribution into the world of real fan performance. I will be still trying to contact different companies, try to get more official PQ curves from them, and if you do it too, start mailing them, start asking for PQ curves, and maybe in future they will be listing them without any issue, without need to request them personally. So that would be it for now. Hopefully you learned something new and you will look at the specs of fans listed by manufacturers completely differently now, or even you won't look at them at all because you understand now they are useless. I really hope I didn't give you much trouble because, well, when I learned about this, the process of picking correct fans to my case, to my radiators IO, becomes much more complicated, but it's better to know the truth than live in a world of lies. With these words, we are going to finish this video, and just to sum up everything, don't believe the CFM in MMH2O characteristic posted by manufacturers on their websites. Look for PQ curves, ask for PQ curves, mail companies directly and want to get that information. And last but not least, look for trustworthy fan testers, Thermal Bench, coolingtechnique, I fully recommend them. And for ease of use, I will be constantly updating this spreadsheet. You can bookmark it. It's shared publicly. Everyone can turn on and turn off these curves, but I don't know how many people will be interested in this, so you might want to make a copy for yourself or download this spreadsheet, because if everyone will start turning on and on these curves, it might be difficult to see anything. Again, thanks for watching and see you later. If you like this video, of course, I recommend liking, maybe subscribing, or just staying tuned for more of my videos. See ya!